Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprint. Still so far we have been as we segmentize two things in electromechanical components. So one we talk about brief about each of the electromechanical components and types of electromechanical component and their applications. Now, next comes why electromechanical components are critical. So, there are certain common parameters which we need to understand why it is so critical when we choose any of the electromechanical components. So, when I say common, parameters, right? So, basically, what has happened? So, there are common parameters like reliability, precision, isolation, and automation, and safety. So when it comes for reliable, right, any electromechanical devices is a combination of mechanical and electrical, right? So mechanical devices basically what happens, it should be very reliable. So when there is a mechanical movement, must be withstand the millions of cycles. So that is define the reliability of the component. So precision very much important when there is an, especially in automotive industry and even healthcare industry and even in the robotics, right? So this is very much needed because the motors and encoders control fine positioning. So this all depends on the control systems and the motor speed. The precise level it defines how critical this component or how big critical for the application. So next comes isolation. So isolation is relay protect control circuit. So when there is a relay used in some of the high voltage control systems, right? So the isolation is it's required to be controlled with relay. Relays play a critical role here. So come for automation. So actuators enable the motion control. So in some of the industrial equipment, if you see the automations and this actuators widely used, right? So next come for safety. See, all along falls under the safety is must when we use any kind of electromechanical devices. So engineers must to understand certain other common parameters called voltage, current rating, switching cycle, torque and speed, stroke length, and duty cycle before selecting a component. So let's understand in deeper some of these critical component and their parameters, right? So first come relay. So high level category comparison. First I want to go with there. Then later we get into each of the sub components of electromechanical devices. So first come relay. So relay, basically the primary function of the relay is electrical switching, right? So when there is an input provided as an electrical signal at a low power, right? So the output would be like electrical connection should be at high power. So when we relay operates in very less voltage, right? So when we inject a kind of when we supply voltage, the output will be transiting into high voltage, high power. So typically usage relays will be in automations and protection circuits. So next comes motor. So motors usually primary function is to electrical to mechanical conversions. Input to always, as you know, this is electrical power as an input is needed. Output would be rotary mechanical motion. So any motor depends on there is a momentum, right? Stepper motor we talk about, and we talk about BLDC motor. So those are the output of expected from the motors. So motion type is continuous and steps. So as we know, right, different types of motor define the motion types, and is widely used in robotics, as you know, in vehicles and even in the fan. Because nowadays, if you see all the different home appliances product, when we say home appliances, specifically the fan operates at a different speed at a different level. So here also you might be notice is combination of rotary switch as well as the motor. So these operates at a certain speed at a certain power when we apply supply to this. Next come for solenoid valves. So when there is a primary function of is this linear actuations. So there is obviously definitely required electrical power. So it's used for linear motion and push pull. Like as I said, solenoid was widely used in landing gear systems. So next comes as an actuators. Actuators, you know, primary function is to control the movement. Obviously, it's required electrical and control signals, because when there is a movement to be controlled with some input to the machine, then we can have the powers to be supplied and send out the control signals to operate at a different speed. And this is widely used in you know, robotics and industrial automations basically. So next comes switches. So as I said, is main function is to manually human can on and off, and is a kind of electrical connection. So when there is an off, there is no power, and when there is on, there is a power to be supplied to the system. So this is again widely used in appliances like consumer electronics and all. Next comes encoders. Encoders is used mainly to see the position feedback, or basically it's used for position feedback, and understand there is a mechanical motion, and the output would be always, if there is a mechanical movement, we do expect electrical signal as an output. It is widely used in CNC and robots and automation systems. Let's compare, like what is the difference between relays, contactors, and switches. So these always create some kind of confusion for us. So let's understand deeper what are these you know, parameters, and what are the different operating mechanism, and what are the difference between all these parameters. So first comes as a function, right? So relays, contactors, and switches, by function wise, relay required at a low and medium power switching applications. Contactors will be required high power industrial switching applications. And switches, as I know, right, is on and off functionality. Control method. So relays will be controlled with electrical coil. Same like contactors also controlled with you know, electrical coil. But switches, as I said, is operated by human. So load capacity, right? So load capacity up to is a moderate load, but whereas contactors is required very when there is an high, very high load systems requirement. So that case, I would say, is used in most of the industrial applications. Switches is low to moderate, right? Typical voltage for, you know, relays would be 5 volt to 24 volts, whereas uh, contactors are required 24 volt to 230 volt, because it's used in industrial applications widely. And so just comes, it depends on the home appliance where we are using. So application wise, uh, this relays will be used in signal controls and automations, and by actuators, sorry, contactors used in motor starter and power grids, and switches will be used in appliances, and when there is a panel board which can be controlled with human operating system. So mechanical durability, if you ask me, relay would be medium range, whereas contactors will be at high because it's used in industrial applications, and switches will be like mediums. So no kind of finding an issue with that. So let's understand motor types and comparison table. So as we discussed, there are you know, 4 different motor type, and DC motor widely used in motion type of the DC motor is continuous rotation. Controlled precision would be at a low, and speed control would be easy, right? And it's operated at a torque at a moderate level. And applications, as I said, fans, toys, and pumps. So these are the places where DC motors are being used. So next comes stepper motor. It you know, motion type would be always step by step, as it name implies. Is a stepper motor is operated step by step, right? And control precision should be at high, and speed control would be at a medium, and torque level of this high holding torque is required, which is widely used in CNC and 3D printers. So next comes for BLDC motor. Motion type would be, I would say, is continuous and should be efficient, and control precision would be medium to high, and speed control should be excellent. So it will be controlled at the proper speed, and torque wise it should be at high. When it comes for applications, right? So applications wise, it's used in drone and EV vehicles basically. So next comes for servo motors. So it's precision controlled motors basically. When it comes for motion, right, it's very precisely controlled. Control precision should be very high. If you lose this precision, then there is no purpose of using servo motor. So speed control should be good because it's used in most of the automotive and aerospace industry. And torque level is high and should be very accurate, and it's used in robotic and automation, as I said. So next comes to understand what is the difference between solenoids and linear actuators, by function, by application, and we can explore. So first comes as a parameter is motion, right? Motion should be instant and push pull for solenoid valve, whereas for linear actuators would be slow and controlled motion. So precision wise, solenoid valve will be quoted as low, whereas linear actuators quoted as an high. Holding force. So holding force means at what speed the control system can be hold, right? So holding speed of solenoid valve would be at high for short period. It should be high and for short period, but whereas linear actuators excellent for continuous load. When there is a continuous load, it should be maintained at a excellent level, holding force. So power usage, yes, solenoid valve high momentary when it comes for power usage, but linear actuators are used moderate and continuous. By application wise, as we discussed, solenoid valves are using locks and valves, whereas actuators will be used in robotics, medical devices, and automations. Next comes for encoder comparison table. When we say encoder, there are different types of encoders. One is optical encoder, other one is a magnetic encoder, and third one is mechanical encoder. So when we say optical encoder, working principle is light interruption pattern. Sorry. So accuracy wise is very high, and output is digital pulse. And applications are CNC and robotics. So magnetic encoders working principle is magnetic field sensing, and accuracy wise it's a medium, and output would be analog or digital, right? So the by application, if you ask me, it is used in automotive and motors basically. So mechanical encoders, the major working principle of this is physical contact switching, right? So accuracy wise is low, and output of this is in digital form, and application wise is used in low speed knobs and audio equipments. So overall, I guess you understand what is mean by electromechanical components and what are those types, and how it is very critical when it's come for usage.